Hey guys, this is Section A3, MSTC Algebra 2. Long time no video. It's good to be back. In 8.3, we are dealing with what's called simple radical form. We are in 8.1 and 2, we talked about the graphs of functions that have radicals in them, and we'll do equations and word problems and all that. But right now, we're just dealing with expressions and making sure they meet three rules, three criteria for being what's simple radical form. These rules in official language are on page 419, and number 1 says this: the radicand of an nth root contains no nth powers as factors. And I am going to simplify that, and just say that your radical is simplified. And that's just meaning to say this: I cannot write a square root that has any perfect squares as factors of the number underneath. All right, in order to be in simple radical form, it has to be simplified as much as possible. And I'm pretty sure everyone has simplified radicals before. So in this case, the radical that goes into 20 is 4, because 20 is 4 times 5. So I'm going to pull the 4 out, and it's going to turn into a 2. And I don't think, like I said, anybody has not done this before. So you just look for perfect squares that go into the number underneath, and if you find one, then you can bring it out and evaluate its square root. All right, this doesn't have to be, it doesn't have to be square roots. It could be cube roots. Example, the cube root of 24. In order to be in simple radical form, I need to have no cube roots as a part of 24. Or, excuse me, no perfect cubes that will go into 24. So just think about your perfect cube numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and my only option here is 8. So since 24 is 8 times 3, then I can evaluate, take the 8 and pull it outside and evaluate the cube root of 8, which is 2, and I'll get the 2 times the cube root of 3. And that will work for, or it's required if you have any root, square root, cube root, any root. Just find those perfect powers inside and pull them out to the outside. If you're not 100% sure of what you've done, type both expressions into the calculator and you should get the same decimal answer for both. So, step 1 into simple radical form is it's simplified. And again, the official language is the radicand of an nth root contains no nth powers as factors, which just basically says this 24 can't have any perfect cubes in it. Otherwise, it's not in simple radical form. Okay, rule number 2, the root index is as low as possible, which means that I cannot write the cube root of something if the square root will do. All right, this is no good if the same expression is equal to the square root of something. All right, I can't have the 6th root if the 5th root or the 4th root will do. So the next logical question is, how do I get that root index? This is the root index here. How do I get that to be smaller? It has to be as small as possible. So let me start fresh here. How are we going to make that any smaller than the way it is? All right, so here's an example. I have the 8th root of 64. Okay, so if you see that you have a root that's a big one like 8, you might suspect that it could be smaller. So how are we going to make it any smaller? Let's start with breaking down 64 into a little bit more manageable numbers. 64, if you did a prime factorization, you did 2 times 32. 32 turns out to be 2 to the 5th. I'll spare you all the whole thing. So anyway, 64 is 2 to the 6th. So I know that this expression is the same as the 8th root of 2 to the 6th. And what we've learned before is that this 8th root is like a 1/8 power. So this is 2 to the 6 over 8. And you can see at this point, hopefully, how this is going to get smaller, because 6 over 8 can be simplified to 3/4. And then I can move backwards, and that 1/4 power is the same as a 4th root of 2 cubed, which is the 4th root of 8. So if you check the 8th root of 64 and the 4th root of 8 in your calculator, you should see that they have the same decimal value. So that's rule 2. If that 8 can be any smaller, right here, then you have to make it smaller. And that will come through a prime factorization. Okay, rule 3. You are not allowed to ever have a radical in the denominator. And while I'm thinking of it, I should have named rule 2. So go back and put root index is as low as possible. So when you look back at this, you'll know what you were doing. We're trying to get that 8 to be smaller. Okay, so no radicals in the denominator. You've probably heard the term rationalizing before. That just means you're not allowed to have usually a square root in the denominator. So have the expression 4 over the square root of 3. All right, this has a decimal value. In some cases later on, you'll just leave it down there, but technically to be in simple radical form, this is a no-no. So what we do is we multiply by the square root of 3 over the square root of 3, thus not changing the value, only changing the way it looks. All right, this is not going to change it because I'm multiplying by 1. Then on top, I get 4 times the square root of 3, and on the bottom, I get 3. So 4 over the square root of 3, 4 times the square root of 3 over 3, those are the same value. They just look different, and the second one is allowed because it doesn't have any radicals in the denominator. So another way you might get rid of a square root in the denominator is something like this. How about 2 over the square root of 3 minus 1? If your square root in the denominator is part of a binomial, it's being added or subtracted to something else, it's not going to do me any good to multiply by the square root of 3 on the top and bottom, like this. Because if I do that, I get 2 times the square root of 3. And on the bottom, when I distribute, I get 3 minus 1 times the square root of 3. And I'm left with that square root of 3 on the bottom like I had before. So that's not my solution. Let's try something else. In order to get rid of a square root on the bottom that's part of a binomial that's added or subtracted to something, what I need to do is multiply by the conjugate of what's on the bottom. All right, square root of 3 minus 1 is conjugate pair with square root of 3 plus 1. All right, I'm still multiplying by 1. I'm still not changing anything. It's just that it's going to change what the bottom looks like, and you'll see what happens here in a second. On the top, I get 2 times the square root of 3 plus 2, because I don't forget to distribute. And on the bottom, I FOIL. And I do the square root of 3 times the square root of 3 is 3. Square root of 3 times 1 is positive square root of 3. Negative 1 times the square root of 3. See what happens there. And minus 1. And, lucky for us, those two are going to go away. And we end up with 2 times the square root of 3 plus 2 over 3 minus 1, which is 2. And if I can, I'm going to simplify this to the square root of 3 plus 1 over 1. I'll just leave that 1 on the bottom out. So that's another way you can get rid of radicals in the denominator by multiplying by the conjugate. That's what happens if you have a binomial on the bottom with a radical in it. All right. Finally, what if you have a different root in the bottom? All right, let's say, for example, you have 4 over the 4th root of 32. Now, what we've done in the past, if it's a square root, you just multiply by that same square root. This is not going to work the same way with a 4th root, because the 4th root of 32 times the 4th root of 32 is the 4th root of 32 squared. And 32 squared is, hang on just one second, (1,024). So if I try to multiply by 4th root of 32 over 4th root of 32, I get 4 times the 4th root of 32 on top, and I get the 4th root of 1,024 on the bottom. Now, my problem here is that 1024 might not fit. My perfect fourth powers, let's see, 3 to the fourth is 81. 4 to the fourth is 256. 5 to the fourth is 625. 6 to the fourth is 1296. And I've passed up 1024, and that was not one of my perfect fourth powers. So it's not going to work to just multiply a fourth power by itself, because the result underneath the radical won't necessarily be a fourth power. If you're just doing square roots, then it will, because you're multiplying a number by itself, and you always end up with a perfect square because you just multiplied a number by itself. So let's be a little more clever in what we choose here to multiply by. So we want to end up with something that will be a perfect fourth power on the bottom. So again, a prime factorization might help. I've got 32, which if I just break down 2, it's 2 times 16, which is 2 times 8. Anyway, 32 is 2 to the fifth. So what I have is 4 over the fourth root of 2 to the fifth. Now, I need a multiple of 4 on the bottom as my power. Right? The fourth root of 2 to the fifth, that's no good. What I need is the fourth root of 2 to the 8th, or the 12th, or the 16th, or the 4th if I was below 4, but I'm already up to 5. So what if I choose to multiply by the fourth root of 2 cubed? In other words, I'm going to multiply by the fourth root of 8. So let's see what happens there. I get 4 times the fourth root of 8 on top, and I get fourth root of 2 to the fifth times 2 to the third, which is 2 to the 8th. All right, and 2 to the 8th happens to be 256. And 256 is a perfect fourth power. Okay, so what I have here is 4 times the fourth root of 8 over the fourth root of 256, and that's one way to think of it as 4. Another way to think of it as 4 is I've got the fourth root of 2 to the 8th, which is the same thing as 2 to the 8 over 4, which is the same thing as 2 to the 2, or 4. 4's cancel. Fourth root of 8 is the only thing that's left over. Okay? So there are 3 separate cases of how you get radicals out of your denominator. If it's a square root on the bottom, just multiply by that same square root top and bottom. Then it works out nice and easy. If it's a binomial with a radical in it, multiply by the conjugate top and bottom, because when you FOIL, all of your radicals go away. And if it's another root besides a square root, choose a version of 1 that's going to give you a multiple of your root index right here. Because 4 goes into 8, I was able to simplify this down, which means 2 to the 8th is a perfect fourth power. Okay, so in this section you have a bunch of expressions, and they are going to be not in simple radical form for one of these reasons, and your job is to fix that problem and put it into simple radical form. All right, so that's your 3 rules. I will see you in class. Young out.